Hi, this is Joe Maciarz from Tutoring Enterprises. Today I'd like to talk about linear equations, specifically the standard form, and what does A, B, and C do. Alright, let's jump over to the graphing calculator and start to examine that. We're going to start by putting in our parameters. A is going to equal 1. We're just going to set it to be that for right now. B is going to equal 1. And we're going to have a little problem with C. We're going to let C equal 1, but you're going to see we're going to get an error here. And I'm not quite sure what's going on. It's apparently keeping C something special for, well, for something internal. But what we can do is just go on to the next letter. We're going to let D equal 1, and we're going to be calling C D. Alright, so there it is, and everything's fine. We've got our three parameters. Now let's talk about the equation. The equation in standard form is ax plus by is equal to c. And typically when we write this out, we're thinking of a, b, and c as being integer values, non-decimal values. Although we can let them be decimals, and that's exactly what we're going to do here, just to examine what a, b, and c are doing. Whoops, sorry, that's got to be d in this case, right? Okay, well, clearly there's our straight line equation. And before we talk too much about this, let me go ahead and quickly just change this color. I want to point out that there's something maybe a little different than you've seen previously going on here with this equation. Typically when we have an equation, especially if you're doing it in the TI 86 or the TI 83, or I think they're into the TI 84, but basically when you type the equation into that calculator, it has to be solved for y in order for the graphing calculator to know how to graph it. Clearly, this one doesn't need to be in that form. This is, in fact, what we might call an implicit form because it's not explicitly solved for y. And this type of graphing calculator can and will graph this type of equation. All right. So with that being said, let's go ahead and choose A and come up here and animate that parameter. Okay. Now we're going to go ahead and let it just go from -4 to 4, and again with our 81 steps. So we'll be going increments of 0.1. And before we play it, let's just go take a look at what's going on. Right now A is 1. We can see that here. B is 1 and D is 1. And we have something interesting going on. Notice that the place where the line crosses the x-axis, and we would call that the x-intercept, the x-intercept is 1. And that's actually true about the y-intercept. That y-intercept right there would be 1. So you might speculate offhand, oh, well, this is going to be really easy because the x-intercept is going to be whatever A is, and the y-intercept will be whatever B is. Well, it's not going to be that easy, and we're going to see that right now. So let's go ahead and hit the play button and see what happens. Okay, well right there we've already got a bit of an issue because while A says 0.3, 0.3 on the x-axis would be over here, and we're way over here. So this is not at all acting like we might have thought it was. And in fact, you're going to see that it's going to avoid actually becoming vertical, and the reason for that has to do with the fact that we are only letting A go from -4 to 4. If we can let A go to infinity, we might get, or negative infinity, we might get our vertical straight line, but we're not going to get that here. Okay, well, what the heck is going on? What is the meaning then, for example, of this? Well, let's take A to be 2 and see if we can get a clue as to what's going on. Here's A being 2, and lo and behold, what we see is that, well, we're not at x equals 2 for the x-intercept. We are at x equals 1/2. So that suggests that what we might look at, and I'm going to come over here and type in a new equation, I'm going to type in x equals 1/2. And you're going to see that in fact that does go straight through that. So we might speculate that what is really happening is A is responsible for the reciprocal of the x-intercept, and that is the x-intercept is 1/A. I'm going to now type that in. We still get the same thing because of course right now A is 2, And let me go ahead and just see if that's the case. I'm going to make this red and make it dashed. The dashed implies that this is not really part of the original line, but it's just something to help us sort of focus in on this particular point. Let's go back over to A now and play this and see what happens. See if we're right. Aha. So we do seem to be right. If we pause it, we can see that indeed the dashed line is crossing right where the green line is. So for example, when this is 0.4, 1 over 0.4, well, 1 over 4/10ths, we would flip and multiply that and get 10/4. 10/4 is the same thing as 2.5, and lo and behold, that is exactly where it is. So we can see that this must be right, that A is really somehow related to the x-intercept, but it's related by the inverse of it. Okay, let's go ahead and play it again. And clearly, as A ends up being 0, the x-intercept seems to go off to either infinity or negative infinity. In fact, kind of watch what this does. As A is getting closer to 0 from the negative side, it starts to really pick up speed going this way. The x-intercept will become more and more negative. And in fact, it's starting to shoot off to the left. And in effect, as we go, I'm going to now control it from here, as we go to negative 0.1 and then finally to 0, it's actually completely gone off to negative infinity at that point. But, interestingly enough, because this is a horizontal line, it's also at positive infinity as well. And so if we continue to go forward, it now starts to come in from positive infinity. So it's as if the negative infinity and the positive infinity are connected in some sense, like in a big circle. And basically, it's just going back and forth from what our value is, which is a 4. We're going to see that that then is going to give us 1/4, all the way to positive infinity. The right switches around to negative infinity and then goes back to negative 1/4. So there it goes. Okay? All right. Well, that's good enough for that particular thing. I'm going to shut this one off. And we're also going to shut down the A, and we're going to go examine B. Now I'm going to give you all of about 3 seconds to speculate what's going to happen to B, how B is going to be related, before I actually go ahead and start to animate it. Now, as you know, usually this screws up the numbers, so it sure did. So we've got -4 to 4 going by steps of 0.1. Okay. All right, now that we have that, what do you think, what kind of equation should we draw that's going to highlight the place where this crosses the y-axis? Well, it's going to have to be a horizontal line, so we know it has to be y equals something. You want to speculate what it is? Well, I'm going to speculate that it's 1 over b. All right, there's our horizontal line. Let me again make it fancy red and dash it. Okay. And at least at this point, it is in fact crossing at the same location as our line is. All right, and let's go ahead back to B, and we're ready to play this. So let's see if we're right, and it does appear so. And it has a very similar behavior. Notice that it's going to basically be going to negative 0.25 right here, as B was at -4, and as B becomes closer and closer to 0, it's going to go to negative infinity, and it's going to show up at positive infinity and come all the way back down to 1/4 for the case where B is equal to 4. Right about there. Okay. All right. So indeed, A and B are related to the x-intercept and the y-intercept of the equation. And I'm going to take you on another video after this one, or a little later after this one, that's basically going to highlight that effect. And it's an equation that the books don't show you called the intercept-intercept equation. But for right now, let's go ahead and look at the last remaining variable, which in this case is D, but remember in the books it's called C. Oops, I forgot to stop that. All right. Let's go ahead now and play with D. Well, what do you think is going to happen when we start to move D? Well, if I could hear you, I could tell you if you're right or wrong, but I can't. So let's animate it and see. So again, we're going to go back over here, and it really loves that negative 39 to 41, and I'm not sure why, but it does. All right, so we're going to go from negative 4 to 4 and see what happens. Ready? Here we go. Oh, okay. So in this case, because A and B are the same values, D is basically, in some sense, affecting both the x and the y-intercept. Now, clearly, one way we could describe this is it's moving the line on a diagonal. The diagonal line that we can talk about is y equals x. Okay, let me again do a little red and dashed line because it's not really the line we're looking for. But you can see that the green line is moving perpendicular to the line y equals x. Okay? And as D is, let's see, over here, a positive value, we can see that it ends up on this side, and when D is going to switch to a negative value, well, boom, it's going to go this way. All right? Notice the special value when D is equal to 0. This is just going to give us a line that happens to be going through the origin. Okay? Well, that's about all we're going to talk about for this one. This is the standard form equation for a linear equation, and typically it's not what I would call real useful. It is usually what they use to find the x and y intercepts, and I'm not going to go over that because I've got a much better way. As I said, the next video that I'm going to do on linear equations, I'm going to talk about something called the intercept-intercept form, and you should really check that one out because it's not in the books. They're not going to show it to you. Well, I shouldn't say they're not going to show it to you. They're going to show it to you, but they're going to show it to you in Calc 3. Yeah, they're going to wait that long to show it to you, and they're not going to show it to you in 2 dimensions. They're going to show it to you in 3 dimensions. I'm going to take you through the 2-dimensional version of this, and it's a lot faster and a lot neater to do. We'll also show you some numerical examples, although we may have to wait for another video after that. Well, that's it for today. Just as a recap, remember that A was to some extent responsible for the x-intercept, although in an inverse way. So was B for the y-intercept, again in an inverse way. And D kind of moved things diagonally, back and forth. It actually affected both the x and the y-intercept. So that's how A, B, and our temporarily replaced C can change the equation. I hope you found this interesting, and I hope you learned something. Let's head over to the final screen now. Again, this was linear equations of the standard form, and we were examining A, B, and C. All right. I'm from A Tutoring Enterprises. That's my business, and my name's Joe Maciarz, and that's my lovely face there. My website is at www.tutent.com. Please check it out. I've got prices on there, where I'm located, what subjects I cover, all of that really good stuff. Also has contact information, some of the stuff you're seeing here. My email is at tutent@neb.rr.com, and my phone number is 402-421-3536. Now, I do online tutoring for basically the entire world, and I also do local tutoring for people that happen to be in Lincoln, Nebraska. If you found that this video helped you, feel free to donate $1 or $2 to my PayPal account at tutent@neb.rr.com, same as my email address. And if it didn't help you, but maybe you're looking at this and saying, well, yeah, but he can really still help me in some of the other things, feel free to give me a call, and we'll set something up and get you going on some, well, whatever help you need, really. I appreciate you watching the video, and I hope you learned something. Thanks.